Hello guys, welcome back to our channel. In the previous video, we discussed about the NAND latch. Today we are going to discuss about the SR flip-flop using the NAND gates. Here you can observe that this is the NAND latch and we are adding an extra signal to the flip-flop, which is nothing but the clock signal. Here in the NAND latch, with respect to the inputs, that means based on the inputs, the output will be changed. But in the case of flip-flop, it will be different. The output will be changed according to the input only when the clock signal is high. Otherwise, if the clock signal is 0, there will be no change at the output irrespective of the input. Okay, so now let's construct the truth table for this SR flip-flop. There, what are the inputs? We have clock, S, R, and the Q bar, right? Before starting constructing the truth table for the SR flip-flop, let us recall the NAND latch truth table, S, R, and the Q bar. Here combination of 0, 0, 0, 1, 1, 0, and the 1, 1. 0, 0 means not used state. You can get the information about the truth table, that means how to construct this truth table, in the previous video. 0, 1 means 1, 0, and the 1, 0 means 0, 1, and 1, 1 is nothing but the memory state. Okay, here I am considering it as a S star is equal to, here what are the inputs? We have S bar into clock bar, right? Which is nothing but the output of this flip-flop. Okay, that means S into clock bar, right? Here R into clock bar, which is nothing but the, and NAND is nothing but the AND operation and applying a complement to that operation. Okay, here SR is equal to S bar into clock. By applying the boolean, we get S bar plus clock bar. Okay, and for R star, R bar into clock bar, and by applying the boolean expression, here we get R bar plus clock bar. Okay, now let us start from the clock 0, and remember that if the clock is 0, irrespective of the other inputs, the output will be no change or memory state. How it will be memory state, I will show you. If clock equal to 0 and remaining inputs are not care, right? So here what we have the expression, if suppose S equal to 0 or 1, here clock is 0. 0 means nothing but the 1. So here S star is equal to 1 and the same as R star is equal to 1. Here 1, 1 means we are in the memory state. So this is a memory state. Now if clock is 1 and SR inputs are 0, 0, that means let us apply here. Clock is 1, so S star is equal to, S bar means 1 plus clock means 1, so here will be 0 and again 1, and R star is equal to similarly 1 plus 0 is equal to 1. Here you can observe that 1, 1 means memory state. This is nothing but initially we are getting the output at this place and we are applying to the NAND latch. Simply referring from the NAND latch truth table, we are getting the output states. Okay, I hope you are understanding. And next clock is 1 and giving other combination 0 and 1. So 0 and 1 means S star is equal to S bar. S bar means 1 and the clock will be 0, so again 1, and R star is equal to R bar, here R is 1, so complement will be 0 and the clock will also 0, so 0. Here what are the combination? We have 1 and the 0. Here 1 and 0 means the output is 0 and 1, so Q is 0 and the Q bar will be 1, and again now 1, 1, 0. Now here S star is equal to 1 means 0 plus 0 is equal to 0, and R star is equal to R, here R is 0, right? So R is 0 means R bar will be 1 and the clock is 1, so clock bar will be 0 is equal to 1. Here 0, 1 means the output will be 1 comma 0, and finally 1 1 1. If all are ones, then s star is equal to s bar means here 1, so here 0, and plus clock is 1, so here 0, so 0, and r star is equal to, r star is nothing but 1 and the 1. Here also same, 0 plus 0 is equal to 0. Here we are getting what, 0 and the 0. So this is what, which is not used state. So it is not used or undefined state. Okay, so this is the truth table for the SR flip flop. Now we will see how to make the Verilog code for this SR flip flop. Okay guys, now start making the Verilog code for the SR flip flop. So for that I am creating a module with the name called SR flip, right? Here I am giving the input and output modules. Here input modules are nothing but the s comma r comma clock, and outputs are nothing but q and q bar, right? So here closing this. Now I am taking some additional bytes called wire. In the theory discussion, we have write the middle of the expressions like s bar and plus clock bar. Here, if we will implement that expression to the wire, so wire I am taking as a wire a comma b. Now assigning a equal to argument s, same or and clock, right? In the same way, I am just copying this and I will paste it here. I am writing the R. So we have get the middle of the terms. Now we will assign the outputs. Assign Q equal to, Q is nothing but AND operation between the A and Q bar. Okay, and Q bar is nothing but the AND operation between B and Q. Okay, now I am closing this module called and module. Now I am writing the test bench. So for that I am writing the module tb. Here what are the inputs registered? S comma r comma clock. What are the outputs? Q comma q bar. Now I am extracting the outputs SR flip one. Here we will write all the inputs and the outputs. S comma r comma clock comma q bar. Okay, I'm going to start this initial begin. I'm giving the monitor command so that we can observe the outputs at the output. Here what we will write, clock equal to percentage b. Mainly the entire flip flop will be depend on the clock signal. Clock b, s equal to percentage b, q equal to percentage b. Sorry, q mean here. R equal to percentage b, and finally q bar. Here what we write, clock s r q q bar. Okay, now I will write giving this clock equal to 0, s equal to initial. Firstly I will give clock equal to 1 and s equal to 0, r equal to 0, I mean r equal to 1, and giving some time delay hash 5. Uh, just copying this. I will give clock 0 here, and now I am going to start, or I will give all the possible inputs to the SR and the or by making the clock 1. 0 1 1 0 and finally 1 1, right? Okay, now I am closing this dollar each and module. Okay, now I am selecting a tools and I am going to run this file. Before running this, yes, here I will save this file with the name called SR flipflop. Yes, here you can observe that initially I give the s equal to 0 and the r equal to 1, so the output is q equal to 0 and the q bar 1. Here we have give the clock equal to 0 and irrespective of the other inputs it will act as a memory, right? So previous is 0 comma 1 and here also 0 comma 1. And for clock equal to 1, if the both the inputs are 0, then also it will act as a memory. Yes, you can see here also it previous input is storing now also. And for the 0 1 0 1 1 0 1 0 and the 1 1, the q and the q bar will be 1 1. So in this way we have developed the Verilog code for this. I hope you understood this video. If you have any doubts, please mention in the comment section. Stay tuned for the next video.